Alright guys, so I'm going to be going over this Algebra 2 Test 1.1 review with you. And we're going to start with number 1. Now, this looks rather daunting, even to me. So I'm going to walk you through it step by step. This video is going to be rather long. It might take me many different recording sessions to get through all this, but I'm going to give you every single solution in full. So please forgive the length of the video because I'm trying to be thorough and I'm trying to remember. Actually, it's not that hard to remember because I feel it just like you do, how difficult this material can be to grasp, especially when you start seeing the mathematical notation. And so there's a problem right off the bat, and that is there is not sufficient space here on this document that you're going to be handed to actually do the work that needs to be done to determine. Just for example, in question 1, we're going to need a lot more space than is given here to determine if this is an inverse or not. Or that these are inverses of one another. So you're going to need a lot of scratch paper, or like we talked about, a spiral bound notebook. And so take this, and my advice is you would only write the answer on this and then reference up here somewhere that there's a, staple your work. That's why I recommend the sheets of white paper. Staple the work for each one, numbered, so it's clearly identified to your teacher where the work is for this problem. So with that preamble out of the way, let's jump in. The way I like to do this, if you haven't seen one of my videos before, is I take the snipping tool and basically I snip out the problem and I create a little copy of it. Okay, and then I paste that copy over here, and then we kind of move our attention over here and actually do the problem. We need to make this stop showing. Turn off the notifications. Okay. All right. So another little introduction, since some of you have never seen one of these videos before. This is a Surface Pro 7 computer, and one of the known issues with this computer is when I'm recording using this software down here called OBS. This is the software a lot of YouTube streamers use. When I'm recording and I'm using this pen, okay, it uses up almost all of the computer's internal resources, and the screen gets very hot, and sometimes it stops functioning. And so that's why I have to record many videos and then stitch them together in this program down here called Camtasia. It's like a video editing software, and then that's what takes so much time. So here's the thing. You're not going to be able to cut and paste this into its own deal. So I'm going to rewrite this because you're going to have to rewrite it, right? So I'm going to do all the work that you are going to do. And I'm going to repeat a statement that I make to my other students at my old school, which is, I am not ever going to ask you to do anything that I will not do myself. So I'm going to start by rewriting, okay, and then I'm going to say state if inverse, okay. It's kind of like a summary of what we were asked to do. And then I'm going to write down what we're given. And we're given h of x equals, and then they give it to us as a fraction, negative 10 plus 4x. I think this is a little bit too difficult for what's, but you know, I'm not the one that wrote it. I'm not in charge. Over 5. And then f of x equals 5x plus 10 over 4. You know, I'm using this digital ruler. I recommend your student ID or a credit card or something, or a ruler, the bottom of a protractor. You want to make straight lines. So state if inverse. Okay. Okay. So state if inverse, and here's what we're given. Now, at this point, it's really important to remember that fifth rule from the packet, which says something like, well, in the context of this example, if h of f of x equals f of h of x equals x, we should add here and both h of x and f of x are functions. Okay, because we would have determined that beforehand. We would say if this is true, so if this statement here is true, then h of x and f of x are inverses. Okay? So that's what they want us to know, is, or tell them, is if these are inverses. And so this is what we have to do. So this is the, you know, how to tell if two functions are inverses. I want to highlight this. Well, I didn't write it straight, so I'll have to make a big highlighter. Oh, and by the way, this is available to you. So this OneNote, this is a program called OneNote that I'm using. And this is actually a class notebook, see? So you can access this from Canvas. I'll actually show you how to do that at some point. But it's in Canvas. You just go down in Canvas on the left side. It says Class Notebook. And then basically you'll open it up and you'll see something like this. And you'll go under Content Library, first 6 weeks. And then you'll see this there. And then you'll be able to see everything I'm writing. Okay? All right, so we got the rule out of the way. And I like colors. Especially with this program, I love making stuff in colors, so I'm going to put this in a huge box. Oops, Well, that didn't work out very well, did it? I'll put this in a box. You got to burn this into your brain, all right? And the best way to burn it into your brain is to just do it a whole bunch. That's how I've learned to do mathematics, is to just do it a lot. Just going to move this up a little bit. All right. So, looking at the rule, if h of f of x equals f of h of x equals x, and both h of x and f of x are functions, then h of x and f of x are inverses. So I suppose question 1 would be, is h of x a function? Okay. Well, how would we determine if h of x is a function? The answer is, if the x's repeat, it's not a function, right? So we could look at that graph if we wanted to and see if any x's repeated. And then we could look at the graph of f of x and see if any x is repeated. So maybe we should start by determining if these are both functions. All right. Now, the way I would do that, the way I would do it in the old days is I would just start plugging numbers in and checking to see if any x is repeated. Right? It takes forever. You put a number here, an output value like 2, and then you solve for x, and then you see what the x is, and then you put in another output value like 0, and you solve for x, and you try 1, -1. You keep doing it, and you see if any of the x's ever repeat. That was before graphing calculators and Desmos was invented. And that's what I'm going to use right now, is Desmos. So I'm going to open up a browser, and we're going to head over to desmos.com. Okay. And I'll include these in here so you can take a look at them as well. We'll go ahead and title this graph. I title it when I save it. Okay, whatever. So the first function is -10 plus 4x over 5. So, and we'll say y equals, open parentheses, -10 plus 4x, and then that's going to be over 5. All right, I can tell you already that none of the x's repeat. Right? It would have to be vertical for the x's to repeat, and it's just a linear equation. So I'm guessing that the second one is also a function. What is it? 5x plus 10 over 4. Okay. So both of these are functions. Now, we don't know if they're inverses, but we know they're functions. Let me save this as number 1, test 1-1 review, Alg 2 academic, and then I'll put the date, 09/02/2021. I'll put my name. Okay. All right. Let me save that. And now, having saved it, I can share it. So share the graph, and let me copy this link. Let me show you something cool. Check this out. If I come over here and paste this link, watch what happens. Just watch. So it generated this picture. It's basically generating a tiny version of Desmos inside of OneNote. Okay? So you can actually interact with this graph inside OneNote. So that's a really cool feature right there. All right, so we established that they're functions. And so now we're going to perform this operation where we check to see if h of f of x is equal to f of h of x is equal to x. How do you do that? This is the hard part, okay? So h of f of x, here's how you write that. H of f of x is equal to h, well, let me write it this way. H of f of x is equal to, now what we're going to do is we are going to replace that x right there with this entire thing. Okay? So it's going to look really weird. Let me show you what I mean. And you're going to think, is he joking? No, I'm not. So that's going to be negative 10 plus 4. And then, look at this. Open parentheses. 5x plus 10 over 4 and then all of that over 5. I think it's important that we understand what is going on. This is f of x, okay? And all this other stuff, just choose a color we haven't done before. All this other stuff is h of x, okay? So we're doing h of f of x, which means everywhere we see an x, we're going to stick the entire function f of x. Okay? Maybe I should have written this initial step to make, because I want to make this clear. I don't want this to just be a totally confusing thing that you don't understand and you somehow muddle through the test and then you forget it immediately and you get out of the class and say, man, I didn't learn anything in there. I want you to actually get this. So h of f of x, we're going to do a preliminary step, is equal to negative 10 plus 4, open parentheses, and then in that parentheses, we are going to stick the entire f of x. That's what's happening, okay? Over 5. So take a look. F of x is equal to 5x plus 10 over 4. And we're going to stick that right here, okay? And that's all that I've done in this second step. So if this is step 1, this is step 2. And now step 3 is just a process of kind of like simplification. You see why I said we needed a lot more space than what they give you in the paper? So now h of f of x is equal to, and here I should point out how important neat handwriting is, all right? Because there's a lot going on here, and if you're just scratching this stuff down real kind of like, you're having a seizure, right? Some of the handwriting I see from students is illegible. For your own mental benefit, take the time to write slowly. I mean, do you see me, or do you sense that I'm in any kind of hurry right now? No. This takes time, okay? Math requires time. It requires you to go slow, take a chill pill, and slow down. 99.99% of the errors come from students trying to rush, combined with students trying to do all of the steps of the problem all at once, okay? Because you're trying to hurry, or you're trying to fit it all into that tiny little area they give you to write. And don't do that, okay? Just ignore all that and do it this way. All right, let's continue. So we're going to rewrite the negative 10 because we didn't do anything with that. And then we're going to rewrite the plus because we didn't do anything with that. But check this out. Right here, right here, I've got kind of a unique situation going on. Because that 4 right there is really 4 over 1. Okay? So when I am looking at it and I see that I'm going to have to distribute the 4 to this fraction here, I notice that this is a numerator. Okay? That 4 is a numerator, and here this 4 is a denominator. Well, guess what that means? They cancel out. Okay? So suddenly the problem is a lot simpler, isn't it? Because now we have negative 10 plus, I've just simplified this down to where we don't even need any parentheses anymore, 5x plus 10 over 5. And now we're going to notice another cool trick. So look at all the numbers here. Look at all these numbers. We've got a negative 10, a 5, a 10, and a 5. What's the greatest common factor of all of those? Five, right? So you can divide all this stuff by 5. Well, what if we did that? What if we divided every single number here by 5? What would we get? Well, here we get a negative 2, right? Here we'd get a 1. Here we'd get a positive 2, and here we'd get a 1, which when you have a 1 in the denominator, you don't even have to write it, okay? So now, step 4, things are going to look a lot simpler. The reason I said this problem is a little, in my opinion, a little hard is sometimes students don't notice these little tricks, and they get stuck thinking, I can't do this because this is too much. But there were some little tricks that made this super easy. So now it's just negative 2 plus x plus 2. Now notice something interesting. What is negative 2 plus 2? If we were to combine these together, what would we get? You would get a 0, right? And the only thing left behind would be x, right? So now, step 5, we just proved something pretty cool. H of f of x equals x. That's very important. It's so important that, I want to put a red box around it, because that was part of the thing we had to prove. Okay? If you look up here, we had to prove that h of f of x equals x. Okay? And we just proved that part. What we're going to do next is find out if f of h of x equals x. And if both of those things equal x, then these are inverses. Okay, so one down. Let's go ahead and highlight this using some pretty colors. More colors. Oh, wow. How about light pink? Okay. See, this is where I can tell the computer is starting to run out of memory on me. See what it's doing there? Okay. So, major achievement to get that done. Now let's try to, before the computer completely crashes, let's try to finish this first problem. So what have we accomplished? Let's figure out what we've accomplished. We have found that h of f of x equals x. And now what we need to do, I see I forgot the closing parentheses right there. And now what we need to do is do the kind of the opposite. F of h of x. Okay? So let's go down here. And now we're going to do, so this, we'll call this, we should call this part part A, okay? Because now we're going to do part B, part B. So, step 1. F of h of x equals, well, what does it equal? Well, we're going to start with the template from f of x. So I'm going to put the 5, and then I'm going to put a huge open parentheses and stick this whole thing in there. And then close the parentheses and then put plus 10 over 4. Okay? That's what I'm going to do. I actually need to make like a copy of this. Because I need to see it. Let me put it over here. I'm just trying to remind myself what was I working with there. Okay, so the first term is a, come on back here, brother. The first term is a 5. Okay, the first term is a 5. So we write 5. And now we're going to put a big open parentheses here. And we're going to write, well, I'm going to do the preliminary step, right? So I'm just going to put h of x first. Okay, and then plus 10 And remember what we're going to do. We are going to stick this whole thing in here, okay, in the next step. That's kind of the reason I wanted to do this intermediate step, to show you what we're going to do. And then over, and the denominator for the f of x function is 4, okay? So hopefully we'll end up with a situation like the first problem where everything simplifies nice and neat. So let's do step 2, okay? And actually do that substitution. F of h of x equals 5, big open parentheses now, negative 10 plus 4x over 5 and then all of that over 4. And once again, I want to ram this home. This is this is this, okay? All this, all right? That's all we did. We just stuck this in here. And I forgot the plus 10, okay? Plus 10. Okay? Now remember, again, we got this cool situation going on where this 5 is actually 5 over 1. So this happens to be a numerator, and this is a denominator, right? So we can cancel those 5s. And that gets rid of the parentheses. So let's do the next step. 3. F of h of x equals negative 10 plus 4x plus 10 all over 4. Okay, so at this point in the previous step, we analyzed the greatest common factor. So let's list out all of our numbers. We got negative 10, 4, 10, and 4. So what's the greatest common factor? 2. So we can divide everything by 2. And if we divide negative 10 by 2, we get negative 5. If we divide 4 by 2, we get 2. If we divide 10 by 2, we get 5. And if we divide 4 by 2, we get 2. Okay? So let's do that. In step 4, we're going to write f of h of x equals negative 5 plus 2x plus 5 all over 2. Now here comes some fun stuff. look at this. What is the sum of -5 and +5? Okay, it's 0. Okay, so that gets rid of these two things. And now we're left in step 5. This is so cool. This is why I like Algebra 2. You get to do the cool stuff. F of h of x equals 2x over 2. And 2 divided by 2 is 1, leaving behind x all by itself. Yay! So in step 6, we're going to write f of h of x equals x. And that is a big deal. So we're going to put that in a box. And we are definitely going to highlight that with a pretty color. Let's choose a different pretty color. Let's go with the greens. Let's do a green. Okay, that's not what I wanted to do. Very important. Okay, so now let's go back and see where we're at. We just proved that f of h of x equals x. And previously we proved that h of f of x also equaled x. So now we've proven both things. So we're going to go down here and bring this all together. And in mathematics, at this level, we're going to write our solution. Okay, so this is like a kind of like a proof. All right. This is where we're proving something to be true. Since, so this is like a sentence, all right? Since h of f of x equals x, and f of h of x equals x, then h of x and f of x are inverse functions. And if you really want to get technical, it's according to the transitive property. Remember the transitive property? If A equals B and B equals C, then A equals C. that's how we prove this to be true. Okay, so we'll put that all in a box as well. This is some high-level math. And we need to give this a color. How about a blue? Like a baby blue. Huh? This is our solution, our proof. Congratulations, okay? If you got this far, you did it. You proved it. Okay, you didn't assert it, you didn't make a conjecture, you didn't guess, you proved it. And now I want to show you a visual proof. Let's go back to Desmos. And let me add y equals x. Let me show you something. Do you see how all of these points intersect here? Okay. What inverse functions are reflections of one another across the function f of x equals x. So let me turn that off for a second. Let me turn all these off. And let me just put in this one. There's f of x equals x. All right. So here's the first function. And then if you reflected that function across that green line, you'd get this function. And so those are inverses, all right? Now, it's important to note that inverse functions don't always intersect. That's why when I tapped on that, that's not so important, right? What's more important is that you understand that you proved that these two functions are inverses of one another. Okay? Now, the reason that I've got a problem with this review, I don't have a problem with it. It's actually not a problem. I don't have a problem with it, right? Because here's the answer, right? There's plenty of space to write yes. Okay, but if that's all you wrote and you didn't show any work and that was the test, well, I don't know how much credit you'd be given, right? So yes implies all of this work. And that is problem number 1. So we're going to stop the recording there because I can sense the computer is about to catch fire. And we'll let it cool down and we'll come back and do recording 2.